Hey. What's going on? What's going on? What's up? That's good to hear. Welcome to our first real kind of coding and instructional meeting of the quarter. The past couple weeks have been mainly introductory, and this is the first time we're making the switch to 4 to 5 instead of 5 to 6. So just raise of hands. I see a ton of new people here. How many of you guys weren't here at the first two meetings but are here now? Sweet. That's awesome. Welcome to the club. It's great to see all you guys here. Um, and yeah, let's get started. Let's get started. We promised housing price prediction, and we are going to get there. We're going to get you guys going with your first real machine learning project of the year. Give you guys a couple challenges, but really the goal of today is to understand how some of these machine learning models work, the math, not too much, but the math behind it, and go over some demos, and then we're going to get you guys hands-on with the code. See how it works intuitively, get you guys some good machine learning practices as a really nice start. And then if you want to challenge yourself, you guys can go for it and then tinker around with it as you guys please. So let's get into it. So I know for those of you guys who weren't here last week, we talked about we've talked about two terms, regression and classification. Regression is where you want to get the most precise. So think about it. I like this weather example, right? I want to predict the absolute degrees. So I want to know if it's going to be 72 degrees Fahrenheit today or if it's going to be 66 degrees. So I'm going to use a regression model for that. Versus, do I want to know if it's hot or do I want to know if it's cold today? I'm going to use a classification model for this one, right? So that brings us into our first term, that's linear regression. So right off the bat, just based off the name alone, what do you guys think it is? You guys, what's up? Sure, yeah, that's pretty much what it is. And don't let the term scare you. It's actually really simple, right? We have a scatter plot. Let me move. Let's say we have a scatter plot over here, and we just need to find like some kind of correlation between the two, right? We have an independent variable, we have a dependent variable, and we're just trying to find thinking like a line of best fit, right? That's that's all we really want to do here. It's simple, it's not scary, and let's go on, right? You've all used this before. How This is a really dumb question. I should see every single person's hands go up. How many of you guys have used the formula y is equal to mx plus b? Yeah, that's all this is. That is all this is, right? Intuitively, we need to find the slope and we need to find the y-intercept for a data set, right? That's all that this is. Let's see with some of you guys. We have a data set here. I have a laser pointer. I'm gonna give this out to one of you guys for you guys to kind of like draw a line here. What do you guys think the line of best fit is? Who wants to go for it? It's up to you. What you got? Perfect. Yeah, sweet. So let me ask you this question actually. Oh, how'd you get that answer? Right. So if you think about it, that's how we do it, right? I remember I was taking a pre-algebra class in like 8th grade, and on a test, I'd get a problem like this, and they're like, all right, draw the line of best fit. And then what's the value at like 15? Instead of they give like 10, right? That's how we do it. Now, how does a computer do this? A computer can't just look at it and be like, yeah, you know, I think it goes over here. And we just take a guess from there, right? We're not planning, the computer is not doing this. So let's take a deep dive into how we can do this with a computer versus just kind of eyeballing it, right? And one of these methods is called least squares regression. Has anyone heard this term before? Sweet, that's awesome. And for those of you guys who don't know, I want you guys to discuss amongst yourself what do you guys think this means, and then I'll call on you after. So based on the terms that we know, what do you guys think it means? I'll give you guys like a minute. Go for it. Alrighty. Settle down. All right. So, uh, I heard a lot of great discussions. Who wants to take a shot at it? Ideally, someone who doesn't know what it is can raise their hand. Who wants to go or I point? No takers. All right. Oh, there we go. What's up? Sure, that's a pretty good guess. Anyone else? All right. Let's do some pointing. Guy in the blue shirt with a backpack. It's all right. Take a guess. Yeah, that's pretty much what it is. So let's take a deep dive into it, and let's see effectively how this is gonna work. And what you said is pretty much spot on. So we're gonna start here. Let's take this random data set, right? And what we're gonna do is we can pick a point anywhere on this line, or sorry, pick a line anywhere on this graph, right? I can pick it over here. I can pick it obviously where it's up here. I can pick it over there. I can even pick it off screen if I want to, right? This line can be anywhere. The point is, we want to find, regardless of where we're starting, we want to find the best spot to move it to so that it best fits our data. Intuitively, I'm looking at this and we're seeing that the line is probably going to be somewhere in the middle here, right? So how do we get from this point to the point that we want to be, right? Like you said, we're going to want to take the distance between each point and the line that we have, and we're going to want to square it. And here's a term for you guys, for those of you taking notes, for those of you who want to remember. The distance between a point and a line is called a residual. And what we're going to do is we're going to square this distance, and we're going to sum them all together, right? We're going to keep doing this, right? And we're going to keep trying to find the minimal distance between our line and the points, right? We want to continue to repeat this process, keep going and going and going until we find the line that has the least sum of squares, right? So we need to keep this going. And here's a good gif of it. So if we start at the bottom, right, we know that we have some insane distances between our points here and our previous line, and we need to move our slope up. So the more we move it up, we're thinking, okay, cool, like we're getting somewhere, but it may not be at the right slope. So how do we adjust this going forward, right? Now, you guys might be thinking, right, we need to pick the least sum of squares, right? What is the most effective and the most efficient way to do this, right? Our model can't just do this right off the bat, right? We can get the sum, but how do we work in the back end to get the actual point, the right, remember what we're optimizing for, we need to find the slope and we need to find the y-intercept, right? So we need to use some other process to help us get that in the back end, right? Let's try and do that, right? Let's introduce some formulas. Let's introduce some math here, right? Not to be too scary. Whoa, that is not very fun to look at. But guess what? It's not that hard. It's not that hard. Let's think about what we just discussed. Let's think about what we just discussed, right? We have our previous cost function, right? We're taking the distance between a point and the line, and we're squaring it. We're going to sum it all together, and we're going to take its average, and that's all that this is doing, right? That's what we just talked about. That's what we just did, right? Now, let's take this further, right? What do we need to find? We need to find the slope, and we need to find the y-intercept. Well, in this function, we don't see that anywhere, right? How on earth are we going to take this function and convert that into something where we can find the right slope and the right y-intercept? Well, let's just change it a little bit. Remember, these are the exact same thing, right? Remember the formula for slope. is y is equal to mx plus b. Well, if this is just that, we can just plug that in right over here. And now we have a way to, with our updated formula, we have a way to take this and actually get the individual pieces with the slope and the y-intercept, so we can now optimize for both, right? Now it's about to get pretty mathy, so do you guys have any questions so far before I go ahead? No. Oh. So we're taking the mean, right? So if we have an n number of points, we're taking the mean of the sum of our squares. Cool? Dope. All right, sweet. So let's get into this process a little bit, right? That is intuitively, if you take a look at here, is what's going on. We have an updated formula, right? We have, before we get scary here, how many of you guys have taken a vector calculus or a 3D class? That's awesome. So if I say the word partial derivative, that's not scaring anyone. All right. Okay, so for those of you who haven't taken any vector calculus class yet, don't worry, don't be scared. How many of you guys have taken just a calculus class? I should see everyone's hands up, hopefully. Yeah, all right. Let's go. Guy who just walked in. All right. All right, so what we need to do is let's take a look once more again at our function here. We have really two variables we need to find, right? That's our m and our c. And we have a third kind of element, which is our sum of squares, right? Which is our output. So we're going to graph this on a 3D plot right over here. So let's say this is mapped over here, right? And what we need to do is we can take the partial derivative of each individual variable that we want to optimize for. So let's say we need to find it for our slope. So we're going to take the partial derivative with respect to m. If we want to find it for our y-intercept, we're going to take the partial derivative with respect to our y-intercept value, right? So each time we do this, and if you take a look at this GIF here, I'm a really big fan of it. So if we take a look, instead of going step by step, all right, is this the minimum? Is this the minimum? Is this the minimum? What we can do is we can actually take larger steps towards the minimum value, and we can take smaller steps once we actually get close, right? Because we don't want to overstep it, but we don't want to understep it either. So if we take smaller steps towards our minimum, we can actually get a more accurate and precise value that way. So let's keep it going, right? So we want to take, and this process, here's a term for you guys, it's called gradient descent. You guys are going to be using this a lot. It's one of the most common terms. And a lot of the times under the hood, we have this going on. And I think this is the best way to kind of put for all you guys out here, right? We have a steep slope, we're gonna go faster down, right? Once you get down, you're gonna take smaller steps until we get to our minimum point, right? Think about a derivative for a second. When you take a look at, let's say you had a parabola like this, and we wanted to find the minimum value. For all my calculus guys out there, how would you find the minimum value of a parabola using a derivative? Yeah. Oh, no. Guy in the back, right? Yeah, exactly. So we want to effectively do the same thing here, right? That's why we're taking these derivatives in the first place. All right. So let's keep it going, right? We don't want this process to go on forever. If we have it go on forever, it's not efficient, and you end up just waiting there forever, right? So let's introduce some new parameters to this, right? Let's say we're like, okay, look, after about 1,000 iterations of this, we want you to stop. All right, I hit 1,000, we're done, right? Or in another case, if you reach a step size that is smaller than 0.001, in this case, right, you can change it. But ideally, once you have a super small step size, you're right at the point where you need to be, and you guys can stop your gradient descent algorithm, right? So let's keep it moving with another example, right? Let's take a look at this data set here, right? We're gonna measure if someone is obese or not obese. Given the process that we just talked about what line would best fit this data. I'm going to call on someone and they can get the laser pointer one more time. Who wants to go for it? Bam. All right, sweet. What you got? Oh, here, I got you. It's the one with the light. Yeah, oh, other way. Around there? Sure. All right. So there are multiple ways we can do this. He said around here, which can work if you ideally if you treat this as a function that we just had, your line looks something like this, actually. So if we use linear regression, what we just talked about, to this data set, we're thinking like, okay, I see two values here. If I'm above a certain threshold, you're probably obese. And if you're below a certain threshold, you're probably not obese, right? In theory, this works. This works great. But let's introduce an outlier, right? Yeah, let's introduce an outlier. Let's say we had a point way over there. What happens? What happens to our line? Exactly. It becomes really, really skewed. And does linear regression work here if you add an outlier over there? I see a lot of shaking heads. That is right. You cannot, if you can, you're not going to get good results, right? So when, yeah, so does least squares regression work here? You can, but should you use it? You probably shouldn't use it here. There are much better methods that we can employ to get more accurate data here. That's where we introduce something called logistic regression and the sigmoid function. Like, whoa, that's a math term. That's a math term. No, don't worry. Don't worry. It's not too scary, all right? It's just the cool S, right? If you look at it and take a look at how that models our data set here, and take a look at how clean it all of a sudden becomes, right? We introduced a simple topic earlier. We said like, hey, if we're above 0.5, then you're probably obese. And if I'm below 0.5, we're probably not obese, right? So doesn't this make this much better? So if I have an outlier way over there, this line still continues here, right? So if I'm above 0.5, I'm still obese. And instead of skewing our data, we now have a function that more accurately represents our data set, right? So I just called this logistic regression. And if you guys remember from earlier, regression is when you really want to find be precise, right? The way I think about it. How hot is it versus, is it hot or is it cold? Well, how is this regression? Does someone want to take a guess? Actually, here, I'll have you guys talk amongst yourself for a couple of minutes. How is this a regression problem versus a classification problem? Y'all talk amongst yourselves, and I'll call on people. Go for it. Yeah, yeah. How much time? 420. That's not bad. Huh? Yeah. All right, it's kind of dying down. Who wants to take a gander? Who wants to take a guess? No one wants to take a guess? Damn. Oh, yeah, we got you. Right. Exactly. So what I really want to hammer home here, right, is while this may feel like, hey, we're doing classification, take a look at the function, right? Take a look at this math real quick. Well, what the heck just happened? Nice. What? All right, we're alive. We're good? We're good. All right. So let's take a look at this function here. Like, hey, that doesn't look anything like what we just talked about, right? Well, this function right here, e to the negative z, all we're doing is we're plugging in a value from our linear function into this function, right? What we are talking about here, there's a difference between pure logistic regression and what we are doing right now. This is using parts of linear regression, and we're incorporating it with our sigmoid function here, right? So let's keep it rolling, right? You can still use linear regression, just use it at your own discretion. You want to use whatever works best with the data set that you have. At the end of the day, it depends on your data. It depends on what it looks like and what you're trying to do. If you feel that linear regression is the best way, and especially our least squares regression is the best way to approach a problem, you feel like, then go for it. But if you feel like the sigmoid curve is the best representative of your data, then that would be perfect, right? Then that would be the best way to approach a problem, then go for it, right? At the end of the day, it's really up to your data and how you want to approach a problem. So let's quickly go into decision boundaries. I'm not going to touch on this too much, but what we want to do is we want to differentiate probabilities, right? We want to be able to say like, hey, beyond this line, this is all admitted students, and this is all not admitted students, right? And what threshold means, what threshold you need to cross to get into one side or beyond another, right? Also, these don't need to be binary. A lot of our examples we're talking about today are binary, but this is only in one use case. You can have multiple variables. You can have multiple classification sets, right? So a couple of announcements. So that's pretty much it for the instructional part. We're going to get into the code in a bit, but we're going to get into a bit of announcements here. So yeah, and what we got lined up for the rest of the week, rest of the quarter, and things that we got going on in general. So you guys have a ton of opportunities to get involved. So tomorrow, we're going to have our Sky's No Limit workshop number 2. And here's Kevin.
Just quick, quick small announcement about this. This is going to be tomorrow, and we got the room. I haven't sent out the announcement on Discord yet, but I will be doing so soon. But we actually got a room. It's E2 280. This is 180. It'll be directly above us. That's where we're going to be holding it. It won't have to be outside. There will be actually a catch-up workshop. So the first half will be for anyone who missed last week's workshop to come by, get caught up and stuff if they want. And then the second half will be actually working on the planned topic for tomorrow, which will be finding data. I'll show you guys a couple of different places to look, what kind of data you should be looking for, and kind of that kind of step of making your own AI or ML project. Yeah.
Question.
Yes, the catch-up workshop is at 4, and I think the actual workshop starts at about 5. It's like 3:55 and 4:55 just because of timing and stuff like that, but yes.
Sweet. Oh, one more. There we go.
We'll see if we can. If we have the ability to do so, because we have a room, we will, but I'm not sure. That's what the catch-up workshops are for. That's also what, we're always available on the Discord and stuff like that. But if it can be recorded, it will be.
Just a quick question to you guys. For all the new guys here, how many of you guys have heard of Sky's No Limit before? Or actually, I'll do this. How many of you have not heard of Sky's No Limit competition before? All right, let's put those higher because I can't really see. All right, perfect. So here's Kevin to tell you a bit more.
Hi. So this is going to be a small repeat for some of you, so I'll try and not go too into depth. But Sky's No Limit is our quarter-long AI competition where you will be building your own AI model. Now, if that sounds daunting, that's why we have these workshops every week where we're going to help show you kind of how to do it and what to do. And this is kind of the competition, or, part of the competition side of the club. And there will be prizes and kind of celebration at the end for everyone who participated.
Yo, hey, we're alive, we're alive. Zoom working? Like, is it proper? All right, sweet. Let me take this back. All right, cool, cool. So that Sky's No Limit. It's like Kevin said, it's our quarterly long competition. We have these workshops for you guys as a way to get your projects going early, so you can start them early. Get these things, get help from Kevin. If you guys have more help, we're always available on the Discord, so feel free to ask at any time. Let's keep this going. So any questions on Sky's No Limit? Boom. All right, sweet. You don't have it? Yeah, I haven't seen it. All right, cool. So sweet. Let's move this on. So our speaker events are going to start this Thursday from 5 to 6 p.m. over Zoom for the most part. We have a sweet speaker lineup this time around. If you guys were here a couple weeks ago for our intro meeting, we have since added 2 more speakers to our lineup, starting with, so this Thursday, we're going to be hosting Professor Jesse Thomason at USC. He's a robotics and natural language processing professor at USC. He's going to talk to us about his research. He's the head of part of the Glamour Lab over there. He's going to talk about where he sees the future of human and robot interaction and some of the research that he's really interested in doing right now. Then on October 26th, this is going to be in person, not on Zoom. We're going to be hosting Mr. Janesh Chabra. He was actually a UCSC alum, and he's currently a senior software developer at Amazon Web Services. He's got a lot to talk to you guys about, more specifically on how AI is changing the way he is working, what some of the projects that he is working on, and where he might want to get you guys involved. Then on November 2nd, we're going to have Mr. Pranav Vempati. He was actually one of the presidents of Sky before we took over. He is a master's student here currently, and he did some work as a software engineer at Lawrence Livermore National Labs. He's going to come in, he's going to talk to you guys about what life is like as a master's student while he's using AI, how he has used AI in his work, and maybe tell you guys a little bit more about how you guys can get involved. The 1 week we don't have a speaker event is going to be November 9th, so we have nothing going on then. And finally, our last 2 weeks, November 16th, Mr. Kumar Chuvakula, he's going to come. He's the CEO of Opsera. It's a company I worked at this past summer. He's going to talk about how AI is changing the DevOps field and how he is taking advantage of it in the products that he's using to make his company grow and continue to push that out there. Lastly, we're not going to have any meeting on the 23rd because it's Thanksgiving, so give thanks. And lastly, on November 30th, we end with a bang. Professor Alexander Lurch at Georgia Tech. He is the head of their computational media and machine learning lab over there at Georgia Tech. He's going to talk about how he's using AI and with his music research and how he's kind of incorporating the two. So we've got a huge lineup this quarter. Save the date if you guys can make it. We're looking to change some of the in-person times to 4 p.m., but some that we have already scheduled for in advance are probably going to stay at 5, but all of these are going to be recorded, and all of them are going to be posted up onto our YouTube channel as well after the fact. So if you haven't done that already, please go like and subscribe to our YouTube channel so you can be up. If you miss a speaker event, all of our information is going to be up there afterwards. So last announcement is SkyJam. Whoa, what's that?
Hi guys, it's me again. SkyJam, we pitched this to you guys at Cornucopia a little bit, but more or less we're going to be doing an additional competition during week 5. It's on November 4th. We, instead of a meeting, we're going to be having this going on. Little 4 or 5 hour competition in this room, most likely, where the goal is to make an agent to play a game that is going to be revealed as we get a bit closer, probably in the week before, and we're going to give some preface for how this is going to work. So basically what we're going to ask you guys to do here, this is for our own internal purposes, so we can figure out how much stuff we need to get in terms of food, drinks, etc., and what we might be able to let companies know in terms of how many people they should expect in case they want to sponsor us. Fill this out if you're interested. This is not necessarily I am going, just an I'm interested type of deal. There will be prizes. We might have a speaker come in. Things are a little bit in flux because it's in the process of being really coagulated, as this is the first time that it's happening. But it's going to be really fun. And if for some reason you have an internet or your phone is dead or you just don't want to fill it out right now, we'll send this QR code or just the link to the Google form in the Discord later today so we can get a bit more accurate on the numbers. We'll leave this up for a sec. Feel free to ask me questions in the meantime. Or, I don't know, do your best stand-up joke. That's good too. Awesome. Everyone good in terms of scanning this? Sweet. Yeah. Okay. That's more or less it for me. Now back to the fun stuff and we're coding.
Sweet. So that's Skyjam. I'm gonna go away from this now. If we're like Jonathan said, we're gonna put this onto our Discord, and you guys will be able to fill it out then, or just come after us. Like, hey, I need to see the QR code. You come after, and you can come talk to us. So let's get into the fun stuff. You don't have to hear me talking for too much longer. If you go to this QR code, tinyurl.com/sky-housing, you will be at a collab notebook page where I've have everything kind of put out set for you guys already. If you guys zoom through it, I have a challenge for you guys at the end. And if you zoom through that, play around with it and see what kind of results you can get. I'm gonna walk through the code for a bit, but if I'll leave this up here, we can start doing the code and stuff.
Yeah, and then as a side note, if you want to edit this, make a copy of the notebook. It will not save your progress. Make a copy of this. If you want to reference it later. Yeah, in the back. Is it not shared? Fix that. So he's going to share it in the meantime. I'll tell some stand up. Was that the same question over on the left side there? Man behind the Mac in the, I don't know, pink shirt. Is that the same question? Just that it's not shared? Sweet. Okay. You need to make it link viewable, basically. Okay, try again now. Just refresh. And if that will fix it, then we're good. Okay, yeah, make a copy of this. If you don't make a copy of this, it won't save your progress. So click the file options and the little bar at the top, select make copy, and then you're gonna be in a funny little doc called copyofhousing.ipy notebook. Yeah, okay. Did you end the recording? And the recording's ending here. So for people online, have fun messing with the code.